Number 4. Challenging one. I didn't realize it was this hard. Okay. So, first thing we do is we look at what's going, we figure out what's going to be going across the top. What letters, variables, they're talking about a lot of things in this problem. How do you know what's going across the top? Whatever it is they're asking for. Assortment, boxes of assortment 1, assortment 2, assortment 3. That's what they want from me, huh? They're saying, hey, in the end, we want to know how many boxes of assortment 1, 2, and 3 you should sell to make the most money, maximize profit. So whatever they're asking for, that's what you put across top. So I'm going to call that X, Y, and Z, and I'll put it across top. That'll be X, Y, Z. Does that make sense? Now that means anything else, any other qualities that they mention, those will go down the side. Are y'all seeing how I do that? That's really important. That'll be really helpful to you in setting these up. So what do I mean? Like, what other qualities? Well, they talk about sour and lemon and lime. Well, that must go down the side. Sour, lemon, and lime. Do you see how I know you don't put sour, lemon, and lime on the top? Why? Why not? How do I know? That's not what they're asking for. If they said in the end, how much sour, how much lemon, then I would put that across the top, right? But they're not. They're saying how much assortment 1, 2, and 3. So that's what goes across. So whatever they're asking for goes across the top. Any other qualities down the side. Okay, that'll be helpful to you. It won't really work on number 6, but it'll work on most of the problems. We'll do number 6 in a second. That one's a special one. All right, so here we go. What does it say? Assortment 1 contains 4, 4, 12. Sour, lemon, and lime. 4, 4, 12. So 4, 4, 12. How do I know? Because that's assortment 1, and it's sour, lemon, and lime. So it goes right down the column of assortment 1, doesn't it? See how I know that? They're saying assortment 1, so that means anything they say is assortment 1 going down 4, 4, 12, sour, lemon, lime. Sour, lemon, lime. For assortment 1. All right, and then assortment 2. I'll come back to the money thing in a minute. Assortment 2 is 12, 4, 4. 12, 4, 4 for assortment number 2, which is my Y variable. Okay, good. And then assortment 3 is 8, 8, 8. Assortment 3 is 8, 8, 8. Like that. That's assortment 3, 8, 8, 8. All right, so that's the normal part of this problem. Now comes the hard part. There's a bunch of other numbers, huh? There's a bunch of other money numbers like everywhere. That's pretty, I didn't realize this one was this tricky. They're asking me for maximum profit. How do I figure that out? Well, it says somewhere, oh, wait, there's one more thing. 5,000 is the sour, that's how much they can make. That's the most they can, sour candies. That's the most sour, that's how many sour candies they have to go in these various assortment boxes. So 5,000 is the amount of sour. Where do you think that goes? It goes on the side for sour, right? And 3,800 lemon and 5,400 for the lime. You all good? Okay. Now, with that in mind, now comes the tricky part. Look what they're saying about when they sell the box. What are they saying? They're saying assortment 1 contains, 4 sour, 4 lemon, 12 lime, and sells for $9.40. So that means assortment 1, which is this. Excuse me. Assortment 1 sells. Excuse me again. For $9.40. Now, that's not the profit. That's how much they sell it for. So, and what they're asking me to do is maximize profit. That's the trick on this one. How do you know how much when they sell a box of assortment 1, let's just do one box. When they sell one box of assortment 1, how much profit do they make? Well, they collect $9.40. That's what they sell. So let's just do assortment 1 up here. So assortment 1, it sells for $9.40, but it costs them something to get it ready, right? So you got to subtract what it costs, don't you? We got to subtract that. So, how much does it cost them to get assortment 1 ready? Yeah, assortment 1. Remember what's in a box? Assortment 1 box: 4 sours, 4 lemons, 12 limes, right? Well, that's why they're telling us somewhere there. It's 20 cents for its cost, manufacturing cost per piece of candy. 20 cents for each sour, 25 for each lemon, 30 for each lime. The sour candies cost 20, the lemon 25, the lime 30. 20, 25, 30. So these 4 sour, so they're going to have to, you're going to have to, what's my pen doing? Oh, sorry, I'm in a little trouble. There we go. You're going to have to subtract 4 times 20. Why? Why am I subtracting that? Because there's 4 sour candies in every assortment 1 box. And those candies cost them 20 cents each. You're going to have to subtract 4 times 25. And you're going to have to subtract 12 times 30. See, that's all the costs of the 4, 4, 12 candies in assortment 1 box. Y'all see that? Right? So they sell assortment 1 for $9.40. But if you want to know, if you want the profit, I'm calculating now the profit. The profit for assortment, for each box of assortment 1. So this is hard. We didn't have to do this. Bless you. We didn't have to do this on any of the other problems, did we? This is harder. Everybody see that? The profit they're going to make for each box of assortment 1 that they sell, they're going to get the $9.40, the sale price, but you got to subtract the cost of the 4 candies at 20 cents each, the cost of the 4 candies at 25 cents each, and the 12 candies at 30 cents each. Well, if you do all that, what do you get? Is it 4? $4? Can we do it?
$4.
What did I do wrong? Is 4?
That's what I got.
I don't know why I can't get it. 9.4. Yeah, 4. So I got 4. So that means $4 is the profit they make on each box of assortment 1 they sell. They get $4 for each box of assortment 1 they sell. So that's what we're going to use in the profit function for assortment 1.
The fire alarm at the gym is a false alarm. Repeating.
I'm so relieved.
The gym is a false alarm.
At the gym. We got to let everybody know, though. All right. Yes. So, okay, so the profit for assortment 1 is $4 then. Now we got to do this whole calculation for assortment 2 and for assortment 3. So the profit for assortment 2, what's it going to be? Well, for assortment 2, that's this one in the middle here. First off, how much do they sell assortment 2 for? Yeah, right there. Assortment 2 sells for 7. So they get $7.60 for assortment 2. That's the sale price. But now you've got to subtract all the costs, right? What it costs them to put that box together to get their profit. So you've got to subtract. What goes in assortment number 2? 12, 4, and 4 of the various candies. Remember, the first candy, the sours are 20, the next one's 25, the lemons and the limes are 30 cents each. That's what they told me. That's what it costs them to manufacture sours, lemons, and limes, 20, 25, and 30 cents each. So therefore, you go 12 times 20, 4 times 25, right? 12 times 20. And you're subtracting these because this is cost. 4 times 25 minus 4 times 30. So what does that come out to be? $3. So they only make $3 for every box of assortment 2. That's the profit. So these are going to go in our Z function in a minute. Is this making sense? That's the profit for each assortment 2. That's going to go next to Y. It's going to be 4x plus 3y, and then we got to do the Z. That's how we're going to determine profit. We want to maximize profit. So they're making us work hard for profit calculations here. Finally, assortment 3. Let's do that one. I'll come down here. Assortment 3. Assortment 3. That one it says sells for, here it is, assortment 3 contains 8, 8, 8 and sells for $11. So 11 minus 8 times 20 cents minus 8 times 25 minus 8 times 30. There we go. Calculate that. I'm getting $5. So each box of assortment 3 gets them a profit of $5. It sells for 11, but you got to pay for all those candies they put in there. So now we have 4, 3, and 5. 4, 3, and 5 as the profits for the different boxes. So I can put that. That's what we're trying to maximize, isn't it? So I can say, okay. Here we go now. We're trying to maximize 4x plus 3y plus 5z. That's what we're trying to maximize. 4x plus 3y plus 5z. See how I wrote that? Because we had 4 for the first one, 3 for the second, 5 for the third. 4, 3, 5. 4, 3, 5. That's what we're trying to maximize. Now we're ready to make our matrix. So let's make it. Questions to this point? So that's profit, right? I had to do all that. I had to do all that hard work to find the profit for each of them. Okay, so let's make our matrix now. Let me bring it back over here. So what is that? 4, 4, 12. So first thing I'm going to do is we go 4, 4, 12. I'm just going to put this stuff right here in the matrix. 4, 4, 12, 12, 4, 4. And 8, 8, 8. Yeah. Okay, good so far. Just put that stuff in the matrix. The 50,000, 5,000, 3,800, 5,400. It's way over in the right. 5,000, 38, 34. 54. That goes way over in the right. Got to leave a little room in there. Remember how we do this? How we turn it from all these equations into a matrix? Now, what do we do with this maximize function? Yeah, we take each of these. Remember what we learned? One at a time, and you jump it. Jump it. Jump it over to the other side. And what happens when something jumps to the other side of an equal sign? The sign changes. That'll become -4, -3. You might wonder, why? Why are we doing that? Because we want all the letters on the left. That's the matrix setup, right? We want X, Y, and Z on the left. Just like these are less than. See how this is X, Y, and Z on the left? We got to do the same thing for the maximum function. So that'll be -4, -3, -5. So -4, -3, -5. We always put that one and then 0 there. Right, because when you move that -4, that 4, 3, and 5 to the other side, they become negative, and then there's nothing on the right side. There's just 0. We good to there? That's what we always do, right? We always put the maximum function at the bottom, and we jump everything to the left, making them negative. That's what we did on all of them. -4, -3, -5. Now, what do we put in that big gap? What's in the big gap that's left? What's that? Oh, right, the slack variables. Yeah, I didn't get what you're saying. Yeah, right. The ones down the diagonal, which represent the slack variables. Yeah. You just go ahead and literally put ones right down the diagonal like that. Ones right in the gap in between ones down the diagonal, and then just fill in zeros everywhere else. Those do represent the slack variables. That's true. There we go. That's what you got to put into your calculator. Type it in and then do the simplex on it. Now, one thing we learned in my office here, well, at least I learned in my office, is that some of these you have to hit the enter button more than once on the simplex program. Yeah, I thought it didn't do that, but I thought I checked them ahead of time. I guess not. You must keep hitting enter until you see the words final matrix. Now, usually that's just one step. I thought they were all one step, but I guess not. So if you hit enter and it does the thing, but it doesn't say final matrix, then it needs to take another step. Just hit enter again. And probably it'll be 2 at the most. And then it'll say final matrix. And that means that's your answer at that point on that. So you would put that in as matrix A. Maybe I'll do that one real quick. Or I'm going to use up all my time probably here. Matrix A. It's, what is it, a 4 by 3, 4, 5, 4 by 8? All right. So enter all those, type them all in and hit enter, enter, enter. Okay, and then second matrix. Oh no, program, huh? What am I doing? Program, then we just hit program, simplex, enter. Yeah, it's not final matrix. My first step is not the final matrix. I have to hit enter again. Oh, and a third time. It took me 3 hits to get to final matrix. Did you guys get that on this one? So I just did this one. It took me 3 times to get to the final. To get to the final matrix, which is, I got 0, 0, 1, 0, 0, 0, 0. (1/8) minus 1/16. Minus 1/8, 1/4, minus 1/8, 3/8, 0, minus 1/16, 1/8, 3/16, 0, 0, 0, 1, and 150. 300, 200, 2750. Y'all getting that? I had to hit it 3 times to get final matrix. But don't go beyond it. Don't hit enter again when you see final, because then you won't be able to scroll over to the right. I don't know if you've experienced that. Just hit enter twice, then you'll see final matrix. Don't hit enter again, because you won't be able to scroll over to the right. If you hit enter too many times, it'll be out of it completely and you can't move the screen anymore. And it's okay, you can just do it again. You have to hit program and just run through it again. If you do that, if you go too far. Just hit enter until you see the words final matrix. And then scoot on over to the right. And there we go. Now, how do we read those answers? What do those answers mean? Remember what we learned? You go back to our setup. Remember it was X first, then Y, then Z, right? So that's the same thing here in our answer. This, let me bring it in here. This is X, this is Y, assortment 1, assortment 2, assortment 3, X, Y, Z. So what is X? If it's, remember what we learned, if it's all zeros and a 1, then you grab where the 1 is and you shoot all the way to the right edge. Remember how you read these matrix answers? If it's all zeros and a 1, which X is column, going down the X column, it's all zeros and a 1, so grab where the 1 is, shoot all the way across 200. So that means X is 200. And then how about Y? Is it all zeros and a 1? Yep. Grab the 1, shoot all the way over. Y is 150. How about Z? Is Z all zeros and a 1? Yep. Grab the 1, shoot over. Z is 300, huh? Z is 300. And then the lower right corner is the profit. That's the profit the company's going to make, $2,750. So that's what the company should do. That'd be the best plan for the company. They should have 200 boxes of assortment 1, 150 boxes of assortment 2, 300 of assortment 3, and they'll make the most profit, $2,750, if they do it that way. That was a hard one. Is that making sense? Everybody good with the simplex method? They don't get much harder than that.
It's going to be this hard on a test.
Anything in the homework's fair game. So now that you've seen it, yeah. All right. So let's set up 6, and then we better get to the next chapter. All right. Simplex for number 6. This is a weird one. Part of a weight reduction program, man designs monthly exercise program, consisting of bicycling, jogging, swimming, like to exercise at most 38 hours, 5 hours of swimming, jogging no more than 12 hours, blah, 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 blah. All right. What are my variables? Yeah, let me give you a second. So remember how let me let you figure out what you go at the top, and I'll let you do that. Give you just a second on that. Let's do what you can there. I'll give you a second. Okay. So what? How do you know what the variables are that we're going to put across top? Whatever they're asking for. Yeah, what are they asking for? Bicycling, jogging, swimming, huh? So bicycling, jogging, swimming. Right across the top. Makes sense? Anything else will go down the side. Now, the weird one on this one is there's only one other quality kind of thing they mentioned. That's calories, and that's actually what you're supposed to maximize. So you maximize number of calories burned. So that's actually our maximize thing. Let me just write that one right now. So calories. We're supposed to maximize calories. Remember, your maximize function, that's called your objective function, is what your objective, your goal. So we're trying to maximize calories. That's why he's exercising. It's his objective. So our objective function, what we're trying to maximize or minimize, in this case maximize, is calories. So what does it say? Calories burned is 200 bicycling, 371 swimming, and what is it? 289. Oh wait, did I do the order wrong there? Now bicycling, you just got to keep the order the same. Bicycling, jogging, swimming. There we go. That's our maximum equation, which is going to become the bottom of our matrix with negatives, you know? So the weird part is where's the rest of the matrix, which I'm going to help you with now. But is everybody good so far? Is that making sense? That's the objective of this problem. That's our goal. We're trying to maximize calories burned. 200 calories for each hour of bicycling. 200 times speed. 371 calories for each hour of jogging. 289 calories for each hour of swimming. So that goes there. So notice that doesn't go down here as the normal table. That's my point. Yeah, maybe I'm not saying that very clearly. It's not like normal matrix. That's going to be at the very bottom of our matrix, right? Look back. See how the maximize, what you're trying to max with this one right here, we maximize 4, 3, 5. That ends up at the bottom. See the 4, 3, 5? Negatives. That ends up negative at the bottom of the matrix, doesn't it? Whatever you're trying to maximize or minimize ends up at the bottom of the matrix. So anyway, that's going to be at the bottom of the matrix later. So what do I do for the rest of the matrix? I simply follow what they say directly. It's not nice. It's not set up to be smooth like the last one was. Well, the last one was hard for a different reason. Anyway, let's just take it really directly straight. Here we go. Where does it say? He would like to exercise at most 38 hours. What does that mean? That means if you add these up, it's less than or equal to 38. Right? Isn't that what he's saying? The number of hours he's bicycling, plus every month, plus the number of hours he's jogging every month, plus the number of hours swimming, is at most less than or equal to, right? 38. That's the first fact. So when I go to the matrix in a minute, that's going to be 1, 1, 1, 38, isn't it? When I go to the matrix in a minute. Let's keep going. What's next? Devote at most 5 hours to swimming. Swimming's at most 5. S less than or equal to 5. Sorry, my S's look like 5s. S is less than or equal to 5. Good. And now here comes the hardest one of all. Jog no more than. What does that mean? No more than. If you're not more, then you're less or equal. It's a fancy way to say less than or equal, isn't it? If you're not more, then you're less or equal. No more than what? Total bicycling and swimming. B plus S. It's weird, huh? But that's what they're saying, aren't they? You see how that's what they're saying? So I've got to turn those into matrix form, which means what? Get the letters on left. I'm going to grab this B and the S and jump them over here. Because when I put it into my calculator matrix, it's got to be, the B first, then the J, then the S.
So they're going to be negative.
Yeah, exactly. So I got to jump them over to put them in right form, don't I? So let's grab this one exactly right. I'm going to jump this B right to there, and this S will have to come over here. So this bottom one will become minus B. The J goes in the middle, minus S, and then there's nothing but 0 on the right side. See how that'll be the bottom one, the third one? So let's get rid of this. It's not there anymore. I rearranged it to be in the right format. Does everybody see that? And when I put it in my calculator, it's going to be minus 1, plus 1, minus 1, and 0, isn't it? When you put it in the matrix. Do you see how we have, whenever you're using a matrix, you have to line everything up, don't you? You have to get all the letters on the left in the right order, numbers on the right. So however the equation comes to you, you got to rearrange it before you put it in the matrix. Good? So now we can make our matrix. Now we're ready to go. How's it going to work? See if I can squeeze it in here. This is 1, 1, 1. So 1, 1, 1, and 38 way over here on the right side. And this is 0, 0, 1, 0, 0, 1, and a 5 over here. And this third one's going to be negative 1, positive 1, negative 1, and a 0 way over here. Everybody good? So this one, this one, this one. And then what goes on the bottom? This guy, the maximum one, always goes on the bottom, doesn't it? How are we doing? Am I moving ahead of you here? I want to make sure you're getting the hang of this stuff. Just making sense? Everybody see what I'm doing here? So the one we're trying to maximize always goes on the bottom. And the way it works is you jump this over, jump this over, jump this over. And they change signs. Right? Because you always have to put the letters on the left. Same kind of thing, right? When you stick something in a matrix, you have to organize it correctly first, which means letters on the left, numbers on the right. So I've got to get that 200B, 371J, 289S on the left, not the right. So they become negative when they move over. So negative 200. I'm running out of room here. Negative 371 and negative 289. And 0 on the right, huh? Because there's nothing left on the right anymore. Everybody good there? Now what are we filling in the gap? What always goes in the gap between the numbers on the left, I'm sorry, the letters on the left and the numbers on the right in our matrix? What goes in the gap? Ones down the diagonal, zeros everywhere else. Every time. So 1, 1, 1, 1. And then just fill in zeros. I'm running out of room completely. There we go. There's the matrix. Type that in. Hit the simplex program. Let's do it. It's 4 by 8 again, isn't it? And then do your program, simplex, and hit it. Yeah, it's going to be more than one step again. My first step, it doesn't say final matrix. So I did my first step, I hit enter again. It does another step, I hit enter a third time, final matrix. It took me, again, I had to go through 3 of them to get to my final matrix. Here's what I got. So, final matrix. So go until you got final matrix. There, did you guys get that? There's the final matrix. Okay, I'll come up here. This is final matrix. Oops. Okay, final matrix. And then how do they go? How do the variables go? Well, remember, the first one's B, J, and S. So you just go back to your original setup to know how to read the answer. It was B, J, and S, wasn't it? The original letters were B, J, and S. So that means right at the top up here, this is B, J, and S. So 1, go across B is 14. J, 1, go across J is 19. S, go across, S is 5. And the number in the lower right is always the thing you're trying to maximize. That's max calories. 11,294. So the max calories is 11,294. And we did it. Is that good? Questions I can answer on that one? Did you guys get that okay? Is your calculator giving you those answers? All right. We good? So practice those for the test. Well, we have a couple weeks. Those are the kind that'll be on test. What's that?
When's the test?
2 weeks from today. 2 weeks from today, the 19th. All right, I'm going to leave that section.